Okay, so I'm going to show you how to prove whether or not a kite is a kite. So here is an example of a kite. Kites A, B, C, D, and AC bisects the kite and creates angle 1 and angle 2. So the first statement is BC, so line BC is congruent to line CD, and that was given. And also AC bisects angle BCD, so this line bisects BCD, and that's true because it was given. So then the next statement we have is that AC is congruent to AC, and that is true because of the reflexive property. So AC is congruent to AC because of the reflexive property. Then you have angle 1 is congruent to angle 2. So these two angles are congruent because it is the definition of bisect. And then the next statement that we have is that triangle ABC is congruent to triangle ACD. So these two triangles right here are congruent because of side angle side. And then the next statement that we have is that line AB is congruent to AD. So these two sides are congruent because of corresponding parts. And we were able to prove this because now that we have proven that the triangles are congruent, we can now prove that these two segments are congruent through corresponding parts. And then you can finally prove that ABCD is a kite because of the definition of a kite. Definition of a kite with two congruent sides. So, yeah. So yeah, that's how you prove whether or not a kite is a kite.
Alright, I gotta prove that ABCD on here is a parallelogram. And we have BCEF here is a rectangle, CB, EF are congruent, CE and BF are congruent, and ED and FA are congruent. So we're going to start out with triangle CED is congruent to triangle, that's not triangle, triangle BA, so that's right here. That's because of side angle side offset, because they have B and F and C and E are congruent. They have these two angles are congruent, ED and FA are congruent. So we can then move on to say line CD is congruent to line BA because of corresponding parts of congruent triangles are congruent. And then, so that's what line CD. So we have these two lines are the same. That'll come into play later. And then BF, which we need for this next step, is congruent to DF because that's given. And then ED plus DF is congruent to EF, and then DF plus FA is congruent to DA. And that is a segment addition postulate. Next we have line DF plus BD is congruent to line DA. Because of substitution. Then line EF is congruent to line DA, but also because of substitution. So now we have CB. Alright, now we can prove that ABCD is a parallelogram because we have AB and CD are congruent here, and we know that EF is congruent to DA, and then we know that EF is congruent to CB, so we know that CB is congruent to DA. So EF, A, B, C, D is parallelogram because they have two sets of congruent sides.
Given that line PR and QS are diagonals that intersect at point T, and that line PS is congruent to QR, line ST is congruent to RT, and line PT is congruent to QT, prove that triangle PQT is congruent to RST. Alright, so first, we know that these two angles are congruent because of the vertical angle theorem, so that would be angle PTQ is congruent to angle STR. That's vertical angle view. And then we know that these two lines are congruent, that these two lines are congruent. So set up ratio, so ST over TQ is congruent to RT over TP, and that's because of the division property of congruence. And now that we know that these two triangles share this angle, they share the same sides because of the division property of congruence. They are similar because of side angle side similarity. So triangle PQT is similar to triangle RST. And that's side angle side similarity.
Okay, given that line TO is congruent to SP, TO is parallel to SP, and TH is parallel to PA, prove that TH is congruent to PA. So we have that line TO is congruent to line SP, and those lines are also parallel, and then line TH is parallel to line PA. So now we know that angle TOS is congruent to angle PSO because they're alternate interior angles, because angle TOS right here and angle PSO right here are congruent because these two lines are parallel and this line is crossing them. So alternate interior angles. And then we also know that angle SAP congruent to angle POHT because of the same reason but different lines. So we know that this line right here and this line right here are parallel, and this line also crosses them. And so this angle right here and right here are congruent. Now we can tell that a triangle THO is congruent to triangle PAS because we have two angles that are congruent, and then this side right here and this side right here are congruent because that was given to us. So angle, angle, side. And so lastly, we can tell that line TH is congruent to line PA because corresponding parts of congruent triangles are
That's true.